Okay, our trig functions allow us to take a look at a right triangle and determine the relationships between the sides, the adjacent side, the opposite side, and the hypotenuse. So what is called the adjacent and the opposites? Well, we're talking about this angle right here, and so it's pretty obvious that the angle that's opposite of it, or the side that's opposite of this angle, is this one, okay? Which means the side that's adjacent to it would be the bottom one here. If for some reason we were looking at this angle up here, well then the opposite side would be A, and the adjacent would be B. And then the other side that's of importance is the hypotenuse, which is the longer side. So, in order to solve for these trig functions, we use SOHCAHTOA, all right? So this is for the sine, the cosine, and the tangent. Sine, cosine, tangent. Just got to remember this, SOHCAHTOA. And this is a little division going on right here between the O and the H. So for the sine, we have opposite divided by hypotenuse. So that gives us right here, sine is the opposite over the hypotenuse. So if I was figuring out the sine of the angle right here, I would be doing the opposite, which, as we said, the opposite to this angle is B, divided by the hypotenuse, which is right here. We call that C, okay? That's sine is opposite divided by the hypotenuse. CAH in the SOHCAHTOA is the cosine, and this is the adjacent divided by the hypotenuse. So if it's now the opposite, we'll be using the adjacent right here, which would be the A divided by the hypotenuse C. That's cosine is adjacent over hypotenuse. And then tangent is the opposite over the adjacent. So if we were looking at this angle right here, it would be this, the length of this side right here, divided by the length of this side right here, okay? So what does that all mean? Well, this describes the relationship of this right triangle as the angle changes here. So for a given hypotenuse length, I can go ahead and try and draw this here. Let's say I made this shorter, okay? Or I made this length less right here. Here's my angle. Here my angle was about 30 degrees. Here I'm going to make it less, all right? And so I have a given C right there. It looks like the opposite side over here got shorter, okay? Because this right here gets less, well then this angle right here is, this length right here is going to get shorter. And as a matter of fact, the length here on the bottom, A, well that's going to get longer, okay? You could see that if for some reason I drew this right here and I made it, it much longer like this, well, the opposite happens. This B right here is going to get much larger than what's shown here, but A right here is actually going to get shorter, okay? So if this gets longer, this gets shorter, and vice versa. Okay? So what this is saying is that the sine helps us to determine the opposite side here, so the sine of this angle. So the shorter that this gets, or the smaller this angle gets, the shorter this side gets. And you can see that what happens if I made this right here all the way to 0, to where, that's not quite like this, but it's a really small triangle right here. I keep getting smaller and smaller, and this angle gets smaller and smaller. But eventually this B right here, you'd think would become 0 because it gets smaller and smaller all the way to 0. So when this becomes 0, I'd say B is 0. So if I come in my calculator here and I put in 0 and I hit sine, I get 0 because that tells us, the sine tells us the relationship of this side right here, okay? Versus if for some reason I swung this all the way up and this got bigger and bigger and bigger, you can tell that this side will get larger, okay? So let's just try, let's say we had 15 degrees, that's bigger, and I hit sine. So 15 degrees is equal to 0.26. Let's do some more. 30 degrees, I keep spinning this, swinging this up even more. Now I'm going to 30, I hit sine. 30 degrees, I'm at 0.5, it's getting bigger. Let's go, let's swing this all the way up here to like 60 degrees, right? 60 degrees, 60, and I hit sine. it's going up to 0.86. So this side is getting longer and longer and longer, and all the way, if I come all the way up here to 90 degrees, you know, my triangle would look a little bit different. I'm gonna come up here, I'm gonna hit 90 sine, I'm gonna get 1. So at 90 degrees, sine is equal to 1. All right? So that's kind of what the sine is showing. And the cosine is the adjacent. So that's kind of telling us, you know, what is happening to this length right here as this angle changes. Okay? So that's what these trigonometry functions are used for, to calculate the relationships on a right triangle between the angle and the length of each side. So we'll go over this quite a bit more. Okay? So if we take a look at the sine function here, let's pull this up. So the sine function can be shown in either radians or degrees. All right. So if we take a look at a circle being 360 degrees right there, okay, that's kind of what this is showing. Or 180 degrees would be considered pi, and this is pi over 2 because half of 180 is 90, and so half of pi would be pi over 2. So this would be my radians, and this would be my degrees, okay? But if we're looking at degrees, and we're looking at sine, and we had a circle right here, and it looks like, you know, as my degrees start at 0 right here, and that was my triangle. We said that this side right here was going to be very small. We actually said it was going to be 0, and let's take a look. If we at 0 right here, it looks like I've got 0, and I'll go ahead and check it again. If I put in 0 here and hit sine, I get 0. Okay, so sine of 0 equals 0. If for some reason I went up to, let's say, 45 degrees right here, and that would be, you know, this length here. Now what is this length? Well, it's a lot more than 0. It's because it got bigger, and so that's looking at it. This is 90. It looks like 45's in here somewhere. But if I hit 45 and I hit sine, and I get sine of 45 equals 0.707. So apparently this length right here is 0.707, and if I marked it onto here, you would see that, well, this is a half. This is apparently a half right here. It's not quite to 1, so yeah, that looks about 0.7. If I kept going with this, and this angle swung all the way up here to 90 degrees, well, then what do we get? Well, it looks like it's, you know, right at the top here, and so if I take 90 and take sine, I get 1. So I could mark that point right there, and that is equal to 1. We can keep going. If we did 100 and let's do 45 more. 90 plus 45 looks like this is now 135 degrees here, right? And I could go and I hit 135 and hit sine, and I'm back to 0.707. So 135 here looks like that's where we were at before. So yeah, it's starting to come down. So as this circle swings around here, the length in the y direction here gets larger. It goes from smaller and gets bigger and bigger and bigger and bigger all the way up to here, and then it starts swinging around. This starts getting smaller and smaller and smaller again. Okay, so that is what the sine is showing, and that's how it's being graphed right here. We'll take a look at that more with a little simulator here. Okay, the cosine works in a similar manner. Okay, and so what the cosine does is it tracks that adjacent side. So you can see that this one at 0 degrees is at 1, whereas the sine, the opposite side, happened to be 0. So this is a very similar curve right here. It's just shifted a little bit, okay? And so if we look at the relationship between the sine and the cosine, you see that these are plots that are 90 degrees out of phase to each other, shifted 90 degrees, which means that, you know, when the sine was here at 0, the cosine was at its maximum length of 1. Okay, and so we do our triangle again. Let's go ahead and draw a very small triangle again. So you had, you know, the triangle here. Let's just do like 1 degree here. You know, this was 1 degree here. You can tell that height of the opposite side, which is what the sine is doing right here, it's going to be very small, and it is very small down here. It's, you know, just barely greater than 0. But you can tell that the length here of the adjacent side, the x side, well, that's really long, and you can tell that's what this blue is charting here, that it's upwards of 1. It is very long. As this starts swinging up, what happens? Well, this side gets longer, and the adjacent side gets shorter. And as it comes up even more, well, the opposite side gets longer, and the adjacent side gets shorter. And that's kind of what this is showing. Is this side gets larger and larger and larger and larger. This side right here gets less and less and less and less. Okay. The other function that we talked about is our tangent right there. And so the tangent, once again, can be done with degrees or radians. And it just says that the tangent function goes to infinity at several points. And what does that mean? Well, that means that when you're talking about getting tangent to a circle, this is my circle. Tangent means kind of where it lays flat on the circle right here. So here it's going to hit these axes, or this axis out here. But as this gets larger, this starts getting flatter and flatter, and tangent at the very top here, it goes to infinity because it doesn't hit anything. All right. So let's take a look at and see what all this looks like on a little bit of a simulator right here. Okay. So what I have is an interactive unit circle, and I can spin this circle around here. You know, here's my 0 degrees, 1, 2, 3, 10, 20, 30, 50, 60, 70, there's 90, 110, 120, 130, 160, 170, there's 180, 190, 110, 200, 230, here's 270, 280, 290, all the way back to 360 or 0. So there's my circle right there, okay? So let's start taking a look at 0 right here, okay? So, and as I get larger here, you can see over here that my green side, the opposite side of the angle, which is marked here in green, it starts getting longer, 0.5, 0.515, 0.537. So the green keeps getting longer and longer and longer, and that's what's being shown here on this sine wave, to where finally when I get all the way to 90 degrees right there, it's at the top, okay? And so because the opposite side is as long as it can get, that means the adjacent side goes to 0 because it's as short as it can get. So if we go back to here, you can see, watch the blue, that's the adjacent side of the angle. Right here, it's maximum of 1, but as the angle gets larger, that blue side keeps getting shorter. The green gets larger, the blue gets shorter, and shorter and shorter and shorter, until finally at 90 degrees, you can see that it goes to 0. But as you keep spinning around, well, then it starts getting longer again, and the green starts getting shorter again, okay? And as you spin around, you'll see it keeps creating this sine wave. The green is the length of the opposite, the blue is the length of the adjacent, and they're 90 degrees out of sync, okay? Because you can't have both of them at their longest point right here. At this point here at 0 degrees, blue is at its longest, green's at its shortest. At this point right here, green is at its longest, blue's at its shortest, and they work opposite. They're out of phase from each other, okay? So what is the tangent? Well, the tangent is this line across the top here that is being depicted here. And so you can see that as it comes up and comes up right here, it comes down, and it does cross this x-axis right here. There it's crossing the x, it's crossing. Once I come up here to 90 degrees, that tangent just goes off into right there. It's going, and just kind of shoots off into infinity because it becomes parallel with the x-axis. But then here it starts coming down again. You can see the tangent is coming down, and the tangent is going to hit right there, okay? And there's my tangent line hitting right there at 0, okay? So this is a good graphical demonstration of how the green, which is the sine, is increasing as the cosine, which is the adjacent blue, is decreasing. And then at this point they change. One starts increasing, the other starts decreasing, and you have your interactive unit circle.